Hello, I'm Grant Graydon, and I figured it might be a good idea to go over some review of Calculus 1 before going into velocity analysis here for you. So first thing I'm going to review is the product rule. It's very simple. So let's say we have a function. Actually, I will call this function x of t. Let's say that it's equal to 2x times cosine of x. And we're looking for the derivative with respect to time, so x prime of t. Well, we're going to need to use the product rule to find the derivative. So the way this works is pretty simple. We have, actually, why don't I just, that was very silly with me. So let's go over the product rule. It's something from Calculus 1. It's pretty simple. Should be pretty easy to remember here, hopefully. But if you don't, no issues. The way the product rule works is it makes it so that it's easy to derive functions like these. So we've got our function here, x of t, and x of t is equal to 2t times cosine of t. And we're asked what is the derivative of that with respect to time. So the way this works is we have two functions because we have two different things using t, which is what we're deriving. So our first function we'll call f, and the second one we'll call g. Now, pretty simple. If f is equal to 2t, f prime is equal to 2. It's just the derivative of 2t. And if g is equal to cosine of t, g prime is equal to negative sine of t. Now just plugging it into the product rule, x prime of t is equal to f prime times g, which is 2 times cosine of t, plus f times g prime. So 2t times negative sine of t. So 2t times sine of t. And because it's negative, don't forget to change this plus right here. And there you go. This is its derivative. All right, so let's do another thing here. Let's try and review the quotient rule. This one's a little trickier, but it's still not too terrible, I don't think, personally. So why don't we say that y of x this time is equal to sine of x divided by x squared. How about 2x squared? And we're asked to find what the derivative of that function is. Well, we're going to do something very similar to the product rule, where we're going to say that the numerator, this is how the quotient rule works, the numerator is always going to be our function f, and the denominator is going to be our function g. So what we're going to do is we're just going to find f prime and g prime and plug it into the quotient rule. So f prime is equal to cosine of x, and g prime is equal to 4x. So now 2x squared, derivative of that is just 4x. Now, plugging that into the quotient rule, we know that 4 prime x is equal to cosine of x multiplied by 2x squared minus sine of x multiplied by 4x, all divided by g squared. So 2x squared squared. So why don't we just simplify this a little bit? What can we, first off, let's just go ahead and make this prettier on the top and get rid of that exponent right there. So 2x squared cosine of x minus 4x sine of x divided by 4x to the fourth. Clean up the way that's written. Looking at this, we can see we can cancel out this 2, make this one into a 2, to a 2. And we can cancel out one of the x's. So that would leave us y prime of x equal to x cosine of x minus 4, or minus 2, sorry. Minus 2 sine of x all divided by 2x cubed. Using the quotient rule, that would be our final answer. All right, next one's the chain rule. This one's probably the trickiest in my opinion. Now, to deal with the chain rule, I think it just honestly requires a lot of experience, but I'm just gonna keep going through this until we have derived everything that has an x in it. So what does that mean? We're gonna do h prime of x. It's going to equal out to be -2 sine of 2x. But we're not done. Because, yes, we have worked with the cosine part of this. We've worked with the cosine part, but we have not worked with what's inside. So we're going to chain rule what's on the inside here. So negative 2 sine of 2x multiplied by 2 because of the chain rule. This is the derivative of 2x is just 2. And so I believe that would mean h prime of x is equal to negative 4 sine of 2x. Let me do another example. Let me double check the validity of this. All right, why don't we do one that brings everything we've just learned or reviewed back into one. So a really bad one. Y of x we'll say is equal to x to the power of 4 times sine of 6x divided by 5x plus e to the 2x. All right, so this is a really evil function, I'll be honest. If you can work with this one, I think that you're going to be Gola for all of this math. So why don't we just recall that the quotient rule states that f prime of g minus f g prime over g squared That's how you derive product rule. States that it's f prime g equals f g. And the chain rule, which if you want to write it more so in writing, let's see what Dr. Sue wrote, does make sense. If we were to write d of beta over, let's say, d of x times dx over dt. Those two would cancel out. You'd be left with. So you can say that d beta over dt is equal to over dx times x dot. I guess you could say. So that's kind of like what the chain rule is saying. Now, for this one right here, we're looking for the derivative. What's the first thing that we want to do? So we're trying to simplify this thing. There's a couple of different ways you could probably go about starting this thing. First thing that I personally would do is I would start out with the quotient rule, just because I feel like that's probably gonna blow it up the most. So I'll just start with the quotient. So for the quotient, we have our numerator, f is equal to x to the fourth sine of 6x. And our denominator, g is equal to 5x plus e to the 2x. Just say that whole thing is one function. We aren't multiplying or anything either, which is nice. So the denominator, we don't have to use any product rule. But guess what? We have to use the product rule for the numerator. So f prime is equal to, why don't I actually make this a little bit easier to read? I'm going to rewrite the product rule using different variables. I'll just rewrite this as a prime of b plus ab prime. So looking at our product rule, we can say this right here can be a, and this one right here can be b. So a equals x to the fourth, b is equal to sine of 6x. Now, that means a prime is equal to 4x cubed, and b prime is equal to, we have to use the chain rule, cosine of 6x times 6, because we're dealing with 6x. So that means that we can rewrite f prime as being equal to a prime b, so 4x cubed times sine of 6x plus x to the fourth multiplied by b prime, which is 6 cosine of 6. Now, why don't we work on finding g prime? G prime is nice and easy for us. So 5 5x turns into just 5. And chain ruling on this right here, e to the power of x is equal to e to the power of x. But since we have 2x in the numerator, we, just like we did for the sign, where we pulled out that 6 by deriving, we're going to do, we're going to pull out that 2x and derive, so we just end up with e to the power of 2, or 2 times e to the power of 2x. So g prime is equal to 5 plus 2e to the power of 2x. Now, looking at the quotient rule, we can just say that our function that we had originally up here, y prime of x, is going to equal out to 4x cubed sine 6x plus x to the power of 4 times 6 cosine of 6x. Multiplied by g right there. So multiplied by 5x plus e to the power of 2x minus x to the 4th sine of 6x multiplied by g prime, which is just that right there. So multiplied by 5 plus 2e to the 2x. Dividing all of that by 5x plus e to the 2x squared. And this is what our derivative will be equal to. You could definitely simplify this a lot more if you wanted to. You could probably, yeah, you could definitely simplify this a lot more by like, well, multiplying these two together, as well as expanding this one out. And there. But I'm not going to do that because I think you get the point. This would be the same thing anyways, and that is a valid answer for your derivative of this function up here. I think that if you can work through this problem, you'll be just fine. You'll be golden. So yeah, I hope this helped.